there's a way to make an entrance.
This is my destiny.
It was now a conspiracy of witches.
Download Veely today.
Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. From deep underground to high in the sky, these heavy metal marvels are essential to our daily lives. But what happens when these massive machines break down? Teams of mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet. Doing the vital repair work to keep these heavy metal wonders of industry alive. On this episode of Mega Mechanics, at the world's largest coal export terminal, leading tradesperson Darren Westwood has a massive 23-tonne gearbox in full swing.
Those coupling bolts have been in service now for 18 years.
And it's a bolt to the finish to get this mighty bucket wheel spinning.
Worst case scenario, one bolt, one shift.
When a 550-tonne excavator calls in sick, maintenance supervisor Kenny Diamond and his team of experts must diagnose the problem.
It's quite urgent we get the job done, as it's leaking oil and we don't want to run it dry.
But a call to duty means there's no day off for this heavy lifter.
This has to go back in today and the machine has to be working at 6 o'clock tonight.
Elsewhere, a very different piece of mining equipment, an underground roof support, needs a lift. But there's a major hitch for mechanical fitter Sean Gunning. The lifting point is missing.
So we're just trying to decipher how we're going to lift this.
What would have been a simple lift just got a lot more challenging.
Trying to find another point where we can lift it up.
And there's no time for gushing at Wivenhoe Dam. Maintenance on the Radial gates requires a skilled team led by a highly experienced dam operator.
Just closing the gate to make sure no one else falls. I'm just going to climb down the ladder.
It's all about pressure. A high-pressure water gun, that is. The world's largest coal export facility is at Port Waratah Coal Services in Newcastle, New South Wales. Every year, Port Waratah's terminals have the capacity to export 145 million tonnes of coal. The coal is transported by train from mines across the Hunter Valley region and loaded onto 1,200 vessels and shipped out to the world. This giant bucket wheel is critical in meeting export deadlines. Known as a reclaimer, it's capable of scooping up 9,300 tonnes of coal every hour. Running 24/7, 365 days a year, reclaimer number 411 has stopped turning for some major maintenance.
Today's task is to remove 411 bucket wheel gearbox. So he's driving the bucket wheel which picks up the coal and delivers it to the conveyor.
Having worked on building these machines himself, Darren Westwood, known around here as Booker, short for the Book of Knowledge, knows the importance of keeping this mega machinery in check and fully operational. Ahead of him is a huge job. Weighing in at 23 tonnes, the massive gearbox driving reclaimer number 411's 30-tonne bucket wheel requires replacing after almost 2 decades of operation. A new gearbox is transported 4,000 kilometres across the country to arrive at the Kooragang coal terminal for the replacement. The gearbox is attached to the bucket wheel drive shaft by 16 large bolts. Taking them out sounds like an easy task, except for one challenging technical issue.
Those coupling bolts have been in service now for 18 years, and past experience has showed us when they're jammed, they take about 130 tonnes of removal. One bolt, one shift. So 16 days of just bolt removal before we could actually remove the gearbox.
Bolt removal is an extremely difficult task which will require a crew of 4 men working 12-hour shifts continuously around the clock. How long it will actually take to remove the gearbox is unknown, but being such a critical piece of machinery means deadlines are tight So the less time this monster's in shutdown, the better.
We've been on this planning process for about 4 weeks. So correlating all the gear, getting the gear together, getting it tested, making sure it works, and then packing it up and delivering to site.
Booker is the master of gearbox removals. He's already been involved in 2 of these heavyweight gearbox replacements on the other reclaimers on site. From previous experience, he knows there will be challenges. Once inserted into the gearbox, these indestructible bolts were never planned for removal. And after nearly 20 years in service, his worst nightmare is they won't come out at all. But the master has a backup for that scenario. Booker's plan B is in the form of 4th-year mechanical fitter apprentice Will Hammond.
From past experiences on other jobs, stud extraction being one of the most critical paths in order to get the gearbox off.
For his final year assessment project, Will designed this bolt removal tool, which has been cleverly called the Nutcracker. Yet to be tested on the job, the device will only be trialled if a bolt becomes stuck in the gearbox coupling.
It's got a 150-tonne hydraulic cylinder mounted inside it, and the idea of that is it supports the remaining studs out.
With Will's hydraulic jack on standby and a new gearbox ready to go, Booker only hopes an agonising history with these bolts doesn't repeat itself. 750 kilometres north, across the Queensland border, near the regional township of Oakey, there's a massive machine flexing its hydraulic muscles at the New Ackland open cut coal mine. This 550-tonne excavator and its monstrous 30 cubic metre bucket should be working in the pit, chewing its way through rock and soil to get to the coal below. While it might look like it's fighting fit, the team are actually trying to get to the bottom of a serious mechanical issue. This morning, the only thing this excavator is doing is creating a massive challenge for the mine's maintenance supervisor, Kenny Diamond, diagnosing a problem in one of the 4 slew transmissions.
It's quite urgent we get the job done, as it's leaking oil and we don't want to run it dry, as it'll seize all the gears in the slew trans.
The job is to remove the slew transmission, also called a slew gearbox, and check the massive part for leaking hydraulic oil. A slew transmission is driven by hydraulic motors off the twin engines on the machine. When the operator moves the controls to slew or turn the body of the machine, the slew transmissions rotate to turn the excavator arm and bucket in a 360-degree swing. The pressure is on. The crew have only one 12-hour shift to have this mining machine back on track. To get the ball rolling, some forensics are happening in the belly of the beast, where oil samples are taken to try and determine exactly what type of oil or oils are leaking from where. Preparing the problematic slew gearbox for removal is Mark Van Dongen, a mechanical fitter with 20 years experience.
We're going to pick this motor up off the top of the transmission here. We're going to take it away with a Franna crane. Then we'll get that out of the way on the ground. We'll come back in, we'll undo all of our transmission bolts that hold the transmission in the frame. Then we'll hoist the transmission out.
But none of the big boys' toys will get fired up for these lifts until some smaller tools clear a pathway through these boom arch hoses to allow overhead access for the crane.
The boys are just going to spread the hydraulic hoses there, just use some come-alongs so we can spread them apart.
A come-along is a hand-operated winch used to separate the arched hydraulic hoses. While further down in the excavator, the hydraulic motor is ready to take flight on the boom of a crane. Despite the time pressure, safety is always on everyone's mind.
I don't want to get hurt. I want to go home to my family at the end of the shift. If there's pressure, it comes with years on the job, but you've still got to make sure that you come out the other end of the job with all your digits and everything in place.
With the motor airborne and out of the way, the team's getting closer to their prime objective, the leaking gearbox. The sooner they can get to that, the better.
If we don't repair this leak and seal, the slew motor will actually run out of oil and seize up, and that'll be the end of the machine.
And that's not Kenny's only concern.
If the digger's not operational by 6 o'clock tonight, they're going to be behind on their overburden.
Having one less excavator working the pit, even for just one shift, means lower production, lower profits, and a pile of overburden that's got to be moved. Getting this done in such a short time frame is a major challenge, considering there's going to be a lot of mechanical detective work to figure out the cause of the leak. Stepping into the unknown, will this machine be ready for a call of duty on the night shift? 940 kilometres north of Oakey is the tropical city of Mackay, a region famous for sugar and mining. The Hastings Deering Asset Solutions Workshop has been charged with overhauling a hydraulic roof support from a longwall underground coal mine in central Queensland. For Sean Gunning, mechanical fitter acting as project lead this morning, the shift is off to an interesting start.
Well, last night, boilermakers have made a mistake, obviously, and cut the main lifting point off.
The crew need to raise this hulk to access a cylinder leg, but there's a problem.
There's supposed to be a lug exactly like that on this side, but in your main weld areas around here, they've obviously found cracking, and hence why they had to cut it off.
The boilermakers on the night shift have cut off the main lifting point.
I don't think the boilermakers would have known that we had to lift it.
Ironically, lifting is what these roof supports are all about, powered down in a workshop. It's hard to take in context these transformer-like components. But hundreds of metres below the surface, this roof support is an integral part of an underground longwall mine. Projects and Overhaul Supervisor Warren Samuel, known around here as Wazza, sees hundreds of these units come through the workshop.
This is just one component out of a complete longwall package. This roof support is about 65 tonne.
Longwall mining is an underground coal mining technique using hydraulic-powered roof supports which are interconnected along the length of the longwall face. Massive shearers cut coal from a wall face, which falls onto a conveyor belt for removal. As the shearer advances along the wall, it exposes an area of the coal seam overhead that's retained by the roof support to maintain a safe working environment.
So these hydraulic roof supports support that by putting anywhere between 1,400 to 2,000 tonnes of pressure back into the roof to be able to hold that strata in position.
To put that in context, each of these roof supports is capable of holding the weight of 4 A330 aircraft. But before this unit can start to support that vast amount of weight, some problem solving needs to happen. With 5 years experience on the job, Sean's using a solid alternative.
We've got some other lifting points just in there. We're just gonna throw some bigger shackles through, and we'll just have to change the lengths of the chain that we've shortened. And hopefully should be all good. So we're just going to put this other shackle on, and then we'll have to move the crane back over that way and lower the chains down.
But jostling bulky machinery is never simple. Time to call in the big guns. Cue the overhead cranes.
A little bit too much for one single crane to do, just because when you go high it sort of picks up a little bit more than 60 tonne, the alarms will start going off because they're only 60 tonne cranes. So here's 2.
With 2 cranes in use, Sean uses a 100-tonne spreader beam to balance the weight. Heavy chains are readied to carry the 65-tonne load.
Because we've had to change the lifting points where we're lifting, we've just got to change the amount of links, how the crane's set up, just to get it to lift evenly.
It's a time-consuming process, adjusting then readjusting chains to get the balance right.
Very heavy. Finger biters, sure. Lots of pinch points.
An hour into the job, and another challenge presents itself for the crew to detangle.
The side seal has been taken off, so the pins that are sticking out, there's little grooves above them. The chain's getting caught in as we're going up, so it's getting tight above the pin, but it's still loose down the bottom from the lifting point, and we needed to get tight.
With delays beyond their control, will the team find a solution to lift a roof support stuck firmly on the ground? 80 kilometres northwest of Brisbane, Sitting steadfast on the stunning landscape of the Brisbane River is the impressive Wivenhoe Dam. This earth and rock structure is 59 metres high and 2,300 metres long. The dam wall holds back the 1.16 million megalitre reservoir when at full capacity. The concrete spillway at Wivenhoe Dam has 5 radial gates, 12 metres wide and 16 metres high. They're among the largest of their type in the world. Each year, the radial gates undergo a crucial safety check of the hydraulic motors and winches, along with raising the gates for a visual inspection. Doug is a veteran dam operator and leading today's radial gate inspection. Having worked here for 22 years, he knows the dam well. During that time, he's witnessed extreme weather events which have relied on his skill as a dam operator.
Done many releases, but when we had a really big rain event.
The decision to build the dam came after the torrential rain from Tropical Cyclone Wanda flooded the Brisbane River, devastating the city of Brisbane and surrounding areas in January 1974. Today, Doug and his team, Matt operating the crane and apprentice Ash, are preparing to retrieve a 63-tonne bulkhead gate stored in a large underground concrete container. Radial gates are the most common type of spillway gate in use today. Water pressure is transferred from the curved face to the radial gate arms, which transfer the load to bearings on either side of the gate opening. A bulkhead gate is inserted vertically in the spillway to hold back the water, allowing the radial gates to open for maintenance. Matt is in charge of driving the enormous crane which straddles the dam wall. Using a remote control, he's able to position himself to monitor operation. The main purpose of the crane is to retrieve the bulkhead gate. It's a slow process moving the crane along the wall.
Well, the biggest challenge for Matt is, of course, lining him up and getting him to go inside the slot. Pretty restricted, the area for to go in.
The procedure relies on Matt's skill and experience to drop the locking hooks into the bulkhead. Slowly raising the bulkhead clear of the concrete container, the enormous size of the gate is revealed. Moving along the dam wall, tracks guide the crane into position. The bulkhead gate is designed to hold back the lake, so it's expertly engineered for weight reduction.
When you look at the gate, it's how it's fatter at the bottom. And that's because there's more head pressure at the bottom, so it exerts more pressure. So as it's going up the gate, you'll see it's getting narrower and narrower.
During the maintenance period, a radial gate is inspected each day until all 5 are done. Today, it's Bay 2. The bulkhead is lined up with the bay using marking indicators to assist Matt to centre the position of the bulkhead in the spillway. Slowly, the bulkhead is lowered into the lake. Matt is constantly watching and adjusting the crane. Fine-tuning guides the bulkhead gate smoothly into the slots.
These little shiny ones here, they're the end rollers. They'll help if going down, so if it's not quite laying straight, the rollers will help it shimmy its way down. Ideally, they won't touch. These other big fellas, they actually take the loads.
With the bulkhead lowered safely into position upstream, water cannot enter through the spillway. The dam serves a dual purpose of water supply and flood mitigation. Operations and dam safety engineer Michael Raymond supports the team that operate the dam during flood events.
The dam won't stop all floods, but it will actually certainly reduce a lot of flooding, and what it does that by slowing the floods down as it travels through the dam.
It's during extreme weather events when the ongoing maintenance operations performed by Doug and his team pay off, ensuring the radial gates holding back the lake are functional at all times. It's been a busy morning, but with a slow-moving crane and 64-tonne bulkhead finally at the bottom of the lake, there's a sinking feeling this job's slipping behind schedule. At Port Waratah, leading tradesperson Darren Booker Westwood and his crew are gearing up for Reclaimer 411's gearbox removal. First up, they need to extract 16 large coupling bolts from the gearbox drive shaft. And with past experience of one bolt, one shift, Booker's hoping history won't repeat itself.
The reason the crew behind us are so big because you've got to use packers and jacks and pressures, and there's a lot of communication with regards to pressure on, pressure off, release, just to remove the bolts.
Bolt removal is a high-risk operation. Working with hydraulic pressure in a confined space environment and at height, these highly skilled mechanical fitters are harnessed onto the work platform. Risk assessments are in place and an emergency rescue plan is on standby. Safety is the name of the game for these guys.
Give it to it.
Working shoulder to shoulder, with all eyes on the bolt, it's a four-man job. The jack operator gives a verbal cue for the pump to start.
Righto, mate, give it to it.
So that's a bolt that's been removed, and it's one of the first ones, and that's why you need so much force. Every time you do 16mm stroke on the jack, then it's got to be replaced with a packer, another 16mm, and we've got to do that over 110mm. The whole bolt length 300mm, so it takes a bit.
Gauging the amount of hydraulic pressure needed to remove the bolts is an indication of whether this job will be delivered on target.
Righto, mate, give it to it.
The crew are using a jack to move this bolt with a high-pressure hydraulic pump with the equivalent force of 50,000 pounds per square inch, or PSI.
Righto, nice and steady.
And it's not moving.
Suck him in.
Time to wind it up a notch to 60,000 PSI.
Righto, Shippy. Nice and steady.
Finally, movement. And the bolt comes free. After almost 24 hours of continuous labour, just 8 of the 16 bolts are removed from the gearbox. The only way to access the remaining coupling bolts is to manually rotate the 30-tonne bucket wheel. It's a dangerous task, and everyone except for the winch crew are cleared from the job site. Communication between the crew is critical, as winches and chains are locked onto the buckets. Turning this titan is a slow task. Finally revealing the remaining 8 coupling bolts. With the bucket wheel rotated and safely locked, Booker's bolt crew are keen to get back on the tools to get the old gearbox out.
Nice and steady. Righto, mate, give it to it. Righto, give it to it.
With patience, determination and focus, these masters at work have cracked the code to remove the bolts. But Booker's been here before, so he's not ready to acknowledge victory.
Don't count your chickens before they hatch, of course we've still got 6 to go.
The crew are so close. They're determined to complete the job on their shift so they can have bragging rights. It's 15 bolts down and 1 to go. Across 3 shifts, Booker's crew removed 16 bolts in 32 hours, a record time. Plans now move to installation of the new gearbox. But a changing weather forecast could mean their biggest dilemma is yet to come. Out on Queensland's Darling Downs, a 550-tonne digger has been taken out of the pit at the New Ackland coal mine to get to the bottom of a mysterious leak in a slew transmission. An issue maintenance supervisor Kenny Diamond and his team need to solve before the night shift.
It's quite urgent we get the job done, as it's leaking oil, and if it runs dry on oil, the gears will seize up and the machine won't be able to swing at all, so it'll be up for a new slew trans.
That's a costly venture that the guys are working hard to avoid.
As soon as we get that slew trans out, we'll know whether it's worse than just the seal.
With the 200-kilogram swing motor out of the way, the slew transmission is next in line for a morning flight on the crane. This hefty passenger weighs in at 2 tons. Mechanical fitter Mark Van Dongen stands by to guide it through the forest of hydraulic hoses that control the boom arm and bucket.
Trying to pull this out. Hopefully we find that the seal's damaged or not installed correctly, and we can rectify the problems.
Mark's keen to get the massive part on the ground and try to work out where the leak is coming from. He's hopeful, but there's a lot of unknowns. The crane makes light work of this solid piece of machinery, cautiously easing it down onto a pallet. After 2.5 hours of hard slog, the real dirty work can begin. With the grease cleared out, a rattle gun is used to remove the bolts and reveal the inner workings of this slippery character. Yet again, the crane's called into service. As the team probe the innards of the slew transmission for answers, the clock ticks closer and closer to the shift change. In tropical Mackay, the mercury is well past the 30 degrees Celsius mark in the Asset Solutions workshop. Overhauling this piece of mining equipment is proving almost as challenging as the job this hydraulic roof support undertakes hundreds of metres below the surface.
It's essentially an evolution of a block of timber that people used to use in coal mines. The hydraulic roof support has evolved into what we see now. Our nickname for that is a chock.
It's the perfect analogy for these massive mechanical wedges which sit between the floor of the coal seam and the roof of the longwall mine. Today's mission, supervised by Wazza Samuels, is to raise the unit to access a faulty hydraulic leg.
Through testing, we found that one of the leg cylinders, which holds the top of the roof support up, has got a leak in it, so we're replacing that out at the moment.
It sounds pretty standard, but not when the machinery weighs 65 tonnes, and not when one of the main lifting points has been removed. Sean Gunning, the fitter on project lead this morning, has been working with Wazza and the crew to wrangle this metallic behemoth into position.
So it needs to be moved forward, it needs to be a stand under the bottom. So we just had to come up with another idea how to do it.
After 5 years on the job, Sean isn't phased.
Fair few jobs come through where you have about 50 to 60 of them, all in a really short turnaround.
But with this particular unit, nothing is happening quickly.
Generally what we will do is we'd do it a lot different to this. We'd have the crane set up holding the canopy up. We'd take the leg out and there'd be a new one to go straight back in. But we don't have any cylinders on hand at the moment, so this one's going to get taken out, which is why we have to put the stand under it.
Progress is slow, but safety is always the top priority. And throughout the operation, Wazza is standing by, ready to give expert advice and hands-on assistance.
No, well, I came from the same place that these guys are now. I don't see why there's any reason why I can't give back if they need a hand. Yeah. I'm just concerned that we're going to put a lot of weight on this once we go to lift it all in one hit. So if we put it back down again, hook the hydraulics up to the front leg cylinders and just take it up so we can remove that.
I think we will be, if we were, we're just going to take the stand out and we're working for you.
Yeah. What do you reckon, Sean?
After 2.5 hours, with stands and chocks in place, will Sean and his team be ready for liftoff? At Wivenhoe Dam, Doug and his crew have just settled the enormous bulkhead gate into place in the spillway to hold back the lake. Before they can open the radial gates, Doug has to remove the crane's connecting hooks from the bulkhead gate.
Just closing the gate to make sure no one else falls. I'm just going to climb down the ladder, go down so we can disconnect the crane.
It's a risky trip down to water level and requires Doug to wear a harness to reduce the dangers of a fall from this height.
Come and do the other one. All clear, Matt. Up we go.
The radial gates have not opened to release water from Lake Wivenhoe since 2011. But when these massive gates open onto the spillway, it's an awesome spectacle. With the bulkhead gate sealing Bay 2, Doug prepares to take vital readings from the hydraulic winch motors, which raise the radial gate.
It's full operational swing. I'll give you a call every metre so you can obtain your readings. Ready when you are, you can start the pump.
As the gate begins to rise, water trapped between the bulkhead floods onto the spillway. It's enough water to fill a family-sized swimming pool. Paying careful attention, Doug checks the pressure gauges.
Every metre we just get our pressure readings. And the different size you can see on the gauges here, we've got the different pressure gauges, the raised, lower and case pressures. So we just record those at every metre interval.
While Doug is doing his checks, he's coordinating with Matt, who's taking readings on gate positioning and pump pressures in the winch room.
Matt, 2 metres, 2 metres. We just have a good look around to make sure the brakes are coming off. These are the brake cylinders here. We've got a pressure relief valve here. We just monitor to make sure it's behaving like it's supposed to.
Doug checks the hydraulics for leaks and keeps an eye on the witness mark and bolt to ensure they're still lined up.
Matt, 8 metres, 8 metres.
With the stopwatch on hand, a record is made of how long the gate takes to fully open.
Just over half an hour.
It's important to check the gate safety mechanism.
Upper limits come on. That's what stopped the gate coming up. And we also check the hydraulic upper limit. There's an emergency upper limit that'll trip if this one doesn't work. Okay, Matt, if you want to shut that down, we'll just have a look at the, see what she looks like while it's up here.
That means this gate is going to get the full once-over. It's all about high pressure. A high-pressure gun, that is. Back at Port Waratah, preparations are underway to remove the gearbox from the boom arm on bucket wheel 411. A 130-tonne crane has been brought on site to lift the 23-tonne gearbox. It's a difficult lift. The weight of the gearbox means the boom arm of the crane will be at full capacity. Chains are attached to linking points on the gearbox, but because of its odd shape and position, each chain link must be meticulously fed out, one by one, to make sure the weight is evenly distributed and level on rising. After hours of preparation, the crane rigger gives the all clear to lift the gearbox. As chains take up the load, slowly the massive gearbox rises upward. Hanging from the outstretched boom, the gearbox is carefully manoeuvred into a shipping cradle beside its replacement. An operation that started 6 hours ago, rigging and lifting the mighty 23-tonne gearbox, is finally complete. But that's only half the job. The team is eager to lift the new gearbox early in the morning. But will a changing weather forecast wreak havoc on Booker's best-laid plans? At the New Ackland coal mine near Oakey in regional Queensland, a brains trust of mechanical experts are using their combined knowledge to try and nut out what's causing a leak in the slew transmission from this 550-tonne excavator.
We've only got a 12-hour shift to get the job done. The pressure's on to get it out as quick as we can in the next few hours, ascertain what the problem is, and then we'll make a decision from there and try and get the machine back on tower for the guys at 6 p.m. tonight.
Time is a constant pressure, and this machine needs to be up and running for the night shift. But the question still remains unanswered. What is causing the leak?
So we replaced these about 1,000 hours ago, and usually we get 24,000 hours, and the ones we've replaced are now losing oil.
More and more parts are removed and checked as the team dig deeper, working to solve this increasingly baffling puzzle. But until the oil samples come back from the laboratory, nothing is definitive.
We pulled this slew box out and we've disassembled it, inspecting everything thoroughly as we went. We can't find any evidence of anything being assembled wrong or anything out of place, so unfortunately it looks like it's okay.
It's an unusual situation where a positive is more of a negative.
I'm fairly disappointed that we didn't find anything. Yeah, I would have loved to have seen something damaged. Would have been, if it was an obvious fix, would have been a lot better, yeah.
A huge effort with no real result, and time is not their friend today.
We're at the point now where we can't continue looking at it. We need to start putting it back together so we'll have it ready for night shift.
Carefully and precisely, the team reassembled this enormous workhorse in just a few hours. It's been a challenging shift all round, and even for this skilled team, it's a huge task ahead.
It'll be a fair effort by everybody here this afternoon, but I'm confident that we'll achieve our goal and get the thing going.
Although the team couldn't find an immediate fix, the excavator was back in service for night shift under close supervision. Several days later, oil tests assisted the mechanics to find the cause of the leak, replacing a pressure valve and solving the mystery. Mechanical workshops are challenging environments at the best of times. One crew in the workshop have been battling with this monster, an underground roof support for a large chunk of the morning. After 2.5 hours of trial and error to get this piece of coal mining machinery safely supported and chained up for a double overhead crane lift, it's crunch time.
It was something this big, 65 tonne. It's not something that you really want to take shortcuts on. We probably go to the nth degree when we're working on the big gear, but it's the same philosophy that we want to take into the smaller gear we work on as well.
Finally, the chains take up the slack, and there's air between the shed floor and this bulky machine. A slight movement in the chains and the roof support jumps. But the experienced team are not fazed. There's a support stand in place for this exact reason. It's a painstakingly slow process, gradually moving the machine up and then forward. Amazing to see this massive piece of machinery seemingly defy gravity. But not for long.
Nice one. Okay, so we'll take chains off. Reposition the barricade.
With the roof support secured and in a safe work area, the real work can start for Sean and the maintenance crew, removing a faulty leg cylinder.
You can get coal, you can get anything in there, and the tiniest little speck of dirt can get inside and wreck the whole seal, which will cause it to bypass it. It won't hold any weight, so the roof support will just start lowering. If that happens, it can just collapse, and if you've got workers under there, it's not a real safe thing.
The guys that work down there do audits across the system, so they'd pick that up pretty quickly and change it out underground, pretty quick smart. So while it's in here in the workshop, we'll take advantage of the fact that we can do it in a workshop environment with an overhead crane.
3.5 hours after the discovery of the removed lifting lug, Sean attaches hydraulic lines to raise the roof support. It's been a massive effort to get to this stage. And finally, the guys get a good look at the rear cylinder. But just like the Mackay heat, the work's relentless. Their next mission, to remove this 3-ton leg. Every year at Wivenhoe Dam, the 5 radial gates are inspected and cleaned. Today the team have been assigned maintenance of gate number 2. Matt doesn't mind working under pressure to remove the thick algae. Checking the radial gate with apprentice Ash, Doug examines the submerged surface from an inspection platform inside Bay 2.
We got no dramas. Not that we found yet anyway. And that's pretty typical.
To protect the metal surface from rust corrosion, the submerged section of gate is painted with a hard-wearing epoxy paint. Previous spot damage is also examined to ensure the integrity of the repair.
This is the patch that we did previously. Now this is a 2-coat epoxy system, high build epoxy. The first coat's a little bit smaller, the next one's a little bit bigger, so it overcoats. So the next one would come a bit bigger like this.
After many years on the job, Doug compares the condition of the gate from his previous inspection. Satisfied it's in good condition, he gives the go-ahead to lower the gate.
All right, here we go.
Checking the winches, Doug has a stopwatch on the lowering gate. It's important to know how long it will take to close completely.
23.35 and 30 going up. Got a bit of 104 tonne assisting it going down.
With the inspection and cleaning complete and the gate secured, the job is done. With a structure as important as Wivenhoe Dam, inspections are crucial and equipment failure just cannot happen.
It's a rewarding job. We maintain the gear and watch it operate.
The ongoing maintenance provided by Doug and his team ensures the radial gates at Wivenhoe Dam will be fully functional at all times. In Mackay, a team of fitters are slowly making progress fixing a leg cylinder as part of an entire overhaul of underground mining roof supports. A big part of this job is problem solving, something fitter Sean Gunning and his crew have put to the test multiple times today with the challenges of lifting this 65-ton giant. It takes teamwork and combined skills to work through these problems.
We've got a lot of great boys and a lot of experience here. As soon as I started, I could just see how well everyone was gelled together, and it's just one big unit basically. Everyone seems to be mates outside of work as well.
After a day of stops and starts, finally the supports are in place and the team can get down to the job they had planned today. A chain block is used to support the 3-ton leg to ease it out.
The time that it takes to do that preparations mean that we can do the job in a safe manner. The most important thing is get home at the end of the day. Spend time with your family and do the things that you enjoy doing.
5.5 hours have ticked by. And success. Finally, the leg cylinder is free. Sean's a happy man.
Glad it's over. You get that on big jobs, but you gotta take what you get and roll with the punches, as they say.
Now that the guys have got the cylinder out, we're going to send that away to our overhaul facility. It'll be pulled apart, put back together again, so they can go back into another roof support. This roof support itself has got another leg cylinder that's ready to go back into it. So tonight, night shift will throw that in, we'll put it back up and begin the rehosing of the roof support.
After several false starts and lengthy delays, the team have pulled together to get the job done. When the rear leg is replaced, this roof support will go back into service at a central Queensland underground coal mine. At Port Waratah, Booker is at the mercy of the weather. His plans to lift Reclaimer 411's new gearbox grind to a halt.
The rain has come in. The forecast is scheduled for about 40 millimetres of rain. So that's come in and impact the schedule.
The work site is a total washout.
The main priority when it rains is that we can't allow people up on steelwork, the slipperiness. It's utmost important that safety is our first priority.
Water, man and machine is a lethal combination, making a 23-ton gearbox lift highly hazardous. And this downpour has dampened any hope of activity on site. Ongoing delays to the maintenance schedule will have a serious impact on operations.
We've got to reschedule shifts and reschedule coal piles and a whole host of things happens.
As the window of opportunity to stay on time and on track slowly closes, Booker needs to look for other options.
The lift that we're going to do today will be cancelled if any sign of high winds because they've got to have control. So it might end up being the night shift will be the best place to do this work today.
Any type of critical lift after dark presents a whole new set of challenges. But right now, the rain is unrelenting. And it's Booker's job to assess the risks and make the call.
Due to the weather conditions, we're going to cancel today's crew and restart the night shift tonight.
As the day shift mechanics head home, it's a huge blow to operations. Right now, the installation of Reclaimer 411's new gearbox is officially off limits. Losing a 12-hour work shift means the night crew clock on for one hell of a battle to get 411 back on track. Mechanical fitter Mark Doll is called in to lead the charge, and there's only one thing on his mind.
100% about safety, making sure everything's all right and ready to go.
Preparing for a moment of reprieve. When it comes, it'll be all hands on deck.
So the torrential rain stopped. It's still a bit windy and we've got scattered showers, and when the opportunity comes, they're setting the lift up now. They've got it slung on the crane. They're going to swing it in.
Mark gets his moment. the rain is predicted to ease off, and he gives the team approval to go.
Heaps of eyes on the job, just seeing where the clearances and that are.
Make no mistake, wet surfaces, night lighting, shadows, and the smallest change in weather conditions, and this lift could quickly become disastrous. From lift up to swing in and descend, the crew's looking to get this done while the rain holds.
The way that the load's rigged up is very important so that we're not having to put it back down on the ground and re-rig it again. So the rigging has to be absolutely spot on.
A 23-ton critical lift is a white-knuckle ride. If the new coupling bolts are to withstand a lifetime in the field, realignment is one of the most critical aspects of this entire operation.
We can roll the gearbox, rotate it manually just by spinning the disc. The bolts have only got 0.1 of the millimetre clearance on them. One big plenty of space at that side.
And it's in.
The gearbox is in position. They've torqued up 4 bolts to retain the weight of the gearbox. It's sitting on the pedestal at the back. The crane's removed.
All that's left are the new bolts. And just to finish off a mechanical fitter's dream, the clearance fit design glides them in with ease.
We'll put 16 on and these blokes will have the bolts torqued up by the morning.
8 hours later, Mark and his team of mega mechanics have done it. It's a spectacularly successful handover to Booker the next day.
Job is now complete, that's why it's nice and quiet. It's finally installed. Just checking the Denso tape on the bolts for corrosion protection.
And to keep the gears lubricated, it's time to fill up the oil.
When it comes to site, it's dry, so we fill them up to the mark. About 680 litres these gearboxes hold.
Will's plan B, the Nutcracker, is shelved for another day. But the hands-on knowledge gained by this final year apprentice is more than enough reward.
Yeah, I've been on the job since the very beginning in the planning stage and seen it progress all the way through to the commissioning, which is quite a rare opportunity, but it's been a really good learning experience for me.
As for Booker, the job's not over until this machine is fully operational. With the gearbox job complete, a full test run is on hold until other maintenance work on the reclaimer is finished.
From our point of view, we just wait the completion of the cable reel work and we can move on. It looks like it's a pretty good job.
Keen to power up this mechanical beast, Booker's on the home stretch. And when Reclaimer 411 is fully geared up, it will be ready to churn through mountains of coal for years to come. Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. From deep underground to high in the sky, these heavy metal marvels are essential to our daily lives. But what happens when these massive machines break down? Teams of mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet. Doing the vital repair work to keep these heavy metal wonders of industry alive. On this episode of Mega Mechanics, it's a mighty service on a massive scale at the mine shop for workshop foreman Graham Mallett and his team.
What we're doing here, it's rebuilds and repairs, major rebuilds and repairs.
Spanners are spinning as a team of hard-working mechanics are on a deadline to give these monster trucks a new lease on life.
We bring it in, we tear it down to its bare bones and rebuild it from the floor up.
And in heavy maintenance hangar number 3, senior licensed aircraft maintenance engineer Charles Lacina oversees an Airbus A330 undercarriage check.
It's a very important part of the aircraft. It takes roughly on touchdown probably about half the load of the aircraft.
A challenging installation on a critical landing gear part hinges on a thread to stay on schedule.
The old nut goes fine onto the old pintle pin, but won't go onto the new pintle pin, so we're not sure why.
A mighty maintenance job on the bucket wheel reclaimer at Port Waratah Coal Services can also mean mega danger for Cannon Ford and the team.
Worst case that could happen would probably be if the bucket just fell.
The crew will need to dig deep to get this giant bucket wheel spinning again.
Massive. It's pretty much an apartment building. When you see it, it's really hard to describe the actual size of it.
And heavy machinery blocking an access road at the New Ackland Coal Preparation Plant has brought operations to a standstill for Maintenance Improvement Supervisor Andy Schooler.
So the machine behind me, the Manitou telescopic handler, has broken down.
It's all hands on deck as Operation Manitou Move gets underway.
There's lots of little sensors in there, and we probably damaged and cut some cables when it failed.
950 kilometres north of the Queensland capital city of Brisbane is the central seaside city of Mackay. Built on sugarcane, but boomed with the mining industry, Mackay is the seaport gateway to the Bowen Basin, the single largest coal reserve in Australia. And it's on these mine sites you'll find hard-working, super-sized trucks, dozers, loaders and lifters. These mighty machines have thousands of moving parts operating 24/7 and need an army of mega mechanics to maintain them. Hastings Deering Mackay has troops at the ready to supply and service a staggering fleet of Caterpillar machinery for both surface and below-ground mining.
What we're doing here, it's rebuilds and repairs, major rebuilds and repairs, the things you can't do on site, the bigger jobs, the multi-million-dollar jobs.
Graham Mallett leads a team of more than 120 staff in the maintenance workshop known as the Mine Shop. Here, their specialty is the Caterpillar 793 mining truck. Standing at 6.5 metres tall and almost 14 metres long, the Cat 793 can carry a payload of over 200 tonnes. Off the factory floor, a 793 is worth around $4 million. But fully reconditioned, the truck costs about $2.4 million with parts and labour. The team are in the process of stripping, reconditioning and overhauling the entire truck. And today, the engine has to come out for replacement.
You'll let the guys know about those final drives here, mate. That's like this.
It's a big job worth big dollars. The C175 engine has 16 cylinders and weighs over 12 tonnes. The engine replacement is worth $700,000 alone. And it will take a team of 2 fitters working intensive 12-hour shifts, 4 days to complete the engine refit. And that's only part of the work required to get this truck back in the mine and earning its keep.
There's an awful lot of money in what these machines do. To pull a tonne of coal out the ground costs maybe $140. These machines can carry close to 200 tonne on the back of them. So after a year of working, you soon make your money back.
After a downturn in the region's mining sector, coal production reduced and maintenance schedules were being held off. But now that's changing and work is back on.
They pretty much work 24/7 out on site. With that, they obviously do an awful lot of hours, typically around that sort of 20 to 24,000 hours. That's when we're starting to see them come in here for these rebuilds.
Over the past 18 months, the demand for quality coal has increased internationally. Mines have rapidly picked up production, putting the trucks back into demanding, round-the-clock operations. As a result, the mine shop is seeing an unprecedented number of service and maintenance requests. Graham has his work cut out for him to keep it all on schedule and relies on his team.
So a couple of the guys working on this one today, we've got one guy, he's been with us an awful long time. He's got close to 30 years experience working on these machines.
Ian Selby started out as a field fitter in the early 80s. After years on location in the mines, he's gained a vast amount of experience.
Yeah, 34 years. I've seen a lot of changes in that time. We've seen gone from purely mechanical engines to the electronic engines of today. You gradually watch the machines become bigger and bigger, and after a while you don't even notice, you know.
A lot of the guys that work for us, they come through apprenticeship, but a lot of the real knowledge is passed from person to person, from the older generation to the new guys coming through. But then also it runs the other way with the younger guys. They're more hot on the digital aspect of the machines now, you know, and they're teaching some of the older guys stuff as well.
With all this knowledge changing hands, there's one thing that can't be changed, and that's delivery deadlines.
We pride ourselves on actually quite a fast turnaround for the industry. We can take a 793 and turn that around in 30 days. That's down from sort of a standard of maybe 7 weeks. It's a lot of pressure, but we've got the right team.
And there's a lot involved. Transport costs, police organised for escorts. So if they say 28-day turnaround, it means 28-day turnaround.
Putting Graham under immense pressure to coordinate a busy workshop with up to 6 rebuilds happening at the same time.
We get a machine that's maybe done 4 years worth of work out on site and it's really in need of a good birthday. So we bring it in, we tear it down to its bare bones and rebuild it from the floor up.
The strip down, service and refurbishment of each truck involves 5,000 individual parts.
Until you hit the key, you are kind of on edge. I mean, the guys are constantly checking, like I'm constantly checking. There's always that chance something not quite plumbed up right, not quite connected right. And yeah, you just might turn the key and get nothing.
With so many trucks on the workshop floor and deadlines that need to be met, will the team piece this beast back together on time? In Queensland's capital city, Brisbane, the airport is connected to more than 54 destinations worldwide. And in excess of 17 million passengers fly in and out every year. But today, planes are being grounded. For maintenance, that is. Just east of the runway, the 28-metre tall doors are being opened at Heavy Maintenance Hangar number 3. This specialised facility is due to welcome an A330 Airbus for a landing gear check-in service. In the air, these planes can reach speeds of up to 900 kilometres per hour. But on the ground, it's a much more cautious pace. A jet blast from the engines could cause extensive damage and injury. So for the safety of people and equipment, the jets are switched off and a tug is used to bring the 187-tonne aircraft to the hangar. Aircraft checks are required at specified flight hours, and today this Airbus is grounded for essential landing gear maintenance. The key job for today is the replacement of a pintle pin, basically a large hinge pin which attaches the landing gear to the aircraft structure. It's a component that absorbs and disperses the high stresses during landing, and maintenance is essential. But before this A330 can roll into the hangar, licensed aircraft maintenance engineer Mick Little and his crew have work to do.
We just do a whole series of checks, airframe and also avionic checks. We really want to test the plane when it's nice and alive. We'll start pulling some ducting, some panels apart to do some leak checking. We'll spin engines. It's just to make sure everything's operating properly. Also with our flight controls, we'll turn off and on some computers.
Under the plane's belly, Anthony Barker is one of many young tradesmen paying his dues, removing hundreds of panel screws.
As we take the panels off, we always inspect them as well, make sure they're all in good condition. This is a job they like giving the first and second year apprentices.
It might be grounded, but there are still plenty of safety concerns in and around the Airbus.
People coming up and down the stairs, walking around the engines and so forth, even with spinning, even with noise.
The job might have just started, but time is on everyone's mind. Aircraft have flight schedules to keep and passengers to move.
We want to get it into the hangar as fast as we can.
But before the landing gear maintenance can get underway inside the hangar, the jet engines need to go for a test spin on the tarmac.
when we run engines, we want everybody away. We have a select crew out there just to do the engine run, so there's no need for everybody to be out there.
Finally, it's time for Mick and the team to get this 60-metre wide Airbus towed into the hangar. It's a highly choreographed process to ensure the aircraft is lined up precisely. A thumbs up signals the all clear as spotters watch the massive aircraft dock into position. With wheel chocks in place, these large aircraft jacks are rolled out onto the hangar floor. Slowly raising the jacks, the team prepare to support the A330 under each wing.
We've got to jack it all nice and level, and we use the plane's computer for that.
And finally, the docks are moved into position. With the Airbus docked and raised to service the landing gear, getting the wheels to touch down on this job is about to screech to a halt. 160 kilometres north of the state capital of Sydney is the Port of Newcastle, the busiest coal export terminal on the east coast of Australia and the location of Port Waratah Coal Services, the largest coal export facility in the world. Each year, over 20,000 heavy haulage trains travel up to 450 kilometres from coal mines across the region to unload at Kooragang Terminal. The coal-laden landscape is a sea of black and yellow, dominated by huge metal monsters. The task assignment today is a bucket change on bucket wheel reclaimer 412. This heavyweight machine tips the scales at 1,200 tonnes and reaches skyward to the height of a 14-storey building. Changing a bucket on one of these giants is a team effort. Managing the maintenance task is Darren Westwood. He's been on the job for 22 years. His workmates call him Booker. It's a nickname for Book of Knowledge.
Today's maintenance task is to remove free bucket. It's been identified as a maintenance concern. It's thinning, so there's a potential cause of failure.
The reclaimer's massive bucket wheel weighs in at 30 tonnes and has 10 rotating buckets, each bucket weighing 2 tonnes. Bucket wear is caused by the reaction of coal against steel. Constant scraping creates friction, causing heat and thinning over time. Regular testing of metal surfaces is undertaken to measure thickness and identify potential cracks. Also on the job today is Cannon Ford, a former apprentice at Port Waratah Coal Services, now working for the company.
So this is what gets ultrasonically tested. So it gets the thickness of the steel, so it'll eventually get thinner and thinner and thinner to the point where it cracks. So that would be a breakdown. So that's what we're preventing here.
To ensure even bucket wear, the entire bucket is replaced, including the teeth.
So the teeth at the front here, you can tell normally this would be a sharp jagged edge when they're new. So these are high strength steel, so they're very hard wearing. So when these start to wear, such as this one here, as you can tell, it's worn, and you know that teeth's worn, the bucket's been digging pretty hard.
To get the job underway, Booker needs to make some calculations.
We'll go over and pick a new bucket up and weigh it. We'll weigh that with the crane scales, and then we'll bring it across here, and then we'll attach the old bucket, because then we know the weight of the new bucket, so we know the resistant weight that we can take.
With his calculations set, the team prepare the bucket for removal. The bucket is held by a steel pin on each side.
These are the major pins that hold most of the weight. They've normally got a wedge in them, but we've taken that wedge out because we were ready for the crane. So that pin takes pretty much all of the weight of the actual bucket, and when it's digging, that will take most of the weight that comes on the front lip.
Working with these machines for many years, this is where Booker's knowledge really counts.
Depending on pin condition, so if we have a stuck pin, this could take 3 or 4 hours.
Running on a prevention rather than cure basis, scheduled maintenance on the reclaimer bucket wheel is carefully planned. But it looks like the team have literally hit their first problem. Could Booker's prediction of a stuck pin be about to come true? 10 kilometres north of Oakey in regional Queensland is the New Ackland Coal Mine, a mining company which takes pride in rehabilitation. Since open cut operations began in 2002, the New Ackland Coal Mine has continuously rehabilitated 500 hectares of grazing land, with mining operations and agriculture working side by side. Today, the annual maintenance shutdown of the coal handling and preparation plant is underway. This 5-storey structure washes, grades and sorts the raw material that comes out of the ground, separating the coal for export and the fill to go back into the rehabilitated land. An army of mechanical fitters and boilermakers are working around the clock to repair, refurbish and replace hundreds of pieces of equipment. It's the perfect partnership of mechanic and machine, until a major breakdown brings the worksite to a standstill. It's News Maintenance Improvement Coordinator Andy Schooler doesn't need right now.
So the machine behind me, the Manitou telescopic handler, has broken down in the middle of working on feeder breaker 101 job.
A telescopic handler, otherwise known as a telehandler, is a multi-purpose machine using a telescopic boom arm. It has the capability of a crane and the manoeuvrability of a forklift to move loads across rough terrain. Rob O'Brien was operating the machine when he realised he had a problem with the telescopic boom arm.
When I was pulling it in, I found that it went a little bit tight, made a noise. We went round the back and had a look, thought, oh my goodness, not good. Hose carriage in the actual telescopic part of the boom had come loose and it virtually punched it out the back. Just all the hydraulic lines and that, it's just like spaghetti in the back of the machine.
The issue is not only that it's broken down and inoperable, the machine is also blocking access to the worksite.
Right in the road, it couldn't have been in a worse spot, really.
Now, with a serious breakdown on his hands.
First thing we can do is I call the supervisor, let him have a look and see what his thoughts are.
With news of the breakdown, Andy's quickly on site to assess the damaged machine.
It's a fairly major breakdown, needs some fairly big repairs done on it. So we're not going to get it going in half an hour.
Which means the maintenance job Rob's working on has come to a standstill.
The transmission senses that the jacks are down, so obviously we can't go forward, can't go back. It won't let the transmission engage anyway.
With the machine unable to move, Andy needs a plan to get this stubborn troublemaker out of the way before there's a Manitou meltdown. Around the clock, the world's airports are incredibly busy places, not just in the terminals or out on the runways. The hangars in Brisbane specialise in heavy maintenance, jobs like landing gear changes or extensive safety checks that can take weeks to complete. Yesterday, Hangar 3 was buzzing with the arrival of an A330. Today, it's just one of many aircraft worked on by various teams, inside and out. These gigantic hangars are dedicated to keeping the flying kangaroos running safely and smoothly under the leadership of Paul Crawford.
We have two main facilities, so Hangar 3, where we are today, which houses our wide-body aircraft, where we can have between 3 and 4 wide-body aircraft under maintenance at any one time, and Hangar 2, where we have our narrow-body aircraft, again up to 4 aircraft. So across the facility we can have 8 aircraft undergoing heavy maintenance at any one time, utilising our staff from our apprenticeship program all the way through to our licensed aircraft maintenance engineers, who themselves can have up to 40 years plus experience.
Under the belly of this Airbus, Ian Spencer, one of the many LAMEs, or licensed aircraft maintenance engineers, is unpacking a pintle pin destined for the landing gear.
Yeah, well, it's probably only 40. Yeah.
Before the real heavy lifting starts, the greaser plug needs to be inserted.
We're going to install this into here first before we put the pin up, just for access. And so we're just organising the right greases and everything at the moment. We're trying to get all the nuts and everything ready. In about 5 or 10 minutes, we should be ready to go.
Basically a large hinge pin, a pintle pin is one of the vital components of the aircraft's landing gear. Before commencing the replacement, Ian inspects the pin removed from the aircraft.
The chrome's gone a little bit. I think we're just going to replace it because it might be damaged that you can't see.
With the new pin prepped, it's time for the team to harness up and take a ride in the elevated work platform. down below, the team make minor adjustments to the gear install stand to carefully manoeuvre Ian into the best position.
Okay, hold it there.
This is where they're aiming for. And a heavy part and cramped conditions are creating a challenge.
Yeah, we can push it in and then turn it in there.
The big pin's all good. It's just this eccentric.
But there's a smaller part not lining up. Ian and the team need to work out what's stopping this puzzle coming together and how to fix it.
This ball here seems to be wider than what's come with the new fitting.
Ian compares the old fitting with the new unit as he and the team try and solve the mystery of why it won't fit. Meanwhile, in another section of Hangar 3, a tug is busy pushing a Jetstar A320 onto aircraft scales. Modifications have been made to this aircraft's interior, and a reweigh is standard procedure.
So because we've vaulted essentially the inside of the aeroplane, they need to know if the weight and balance has changed and if the centre of gravity of the aircraft's changed for in-flight characteristics. We've pushed the aircraft onto the scales and off the scales twice to get an average.
A weight and balance officer certified by the Civil Aviation Safety Authority oversees the procedure.
So he is the one that signs off on the readings on the scales and works out the centre of gravity. When he's happy, that's when we're happy.
Happiness is not something being experienced by Ian and his co-workers at the moment, while they continue their efforts to install the new pintle pin. It seems the locking pin is creating an issue, and a bore gauge shows the bearings are slightly smaller than the old one. Team leader Charles Lacina lends a hand troubleshooting.
We had to remove the pintle pin again, and now we're going to have to hone out the bushings in the pintle pin so the lock pin can go in. And for that we have to take it out, take it into the fitting shop, and the fitters have got specialised equipment to hone out the bore.
A few minutes in the hands of an experienced machinist and...
Beautiful.
Will the pin make the grade this time? Something that does seem to be measuring up is the A320. It's a tick of approval from the CASA certified weight and balance officer as this heavy weight rolls off the scales. Good news here, but not back in the wheel well. A nut required to secure the pintle pin is now causing some problems.
So we should check this nut right on the bench.
So, it's back into problem-solving mode again for Ian and the team. But finicky parts are nothing new to these seasoned engineers. Back at the Mackay mine shop, the maintenance team is in the thick of a 28-day rebuild on a Cat 793, a 2,000 horsepower beast of a truck, barely recognisable without its supersized wheels and huge 200-ton tipping tray.
One of the biggest challenges with the jobs being so big is doing 6 or 7 of them at a time.
A 793 mine truck has over 5,000 individual working components.
Awful lot of people to manage, an awful lot of parts to receive.
And like any mechanical service centre, it all comes down to parts being on hand the moment you need them.
The other thing we need to do is just continue to follow.
Mark Farmer is warehouse operations supervisor of the Mackay Parts Warehouse and a handyman to know when you need to find a part.
Anything from a small O-ring up to a large engine that can weigh up to 18 tonne and be valued at nearly $500,000. So very, very diverse type of parts, and with those come their own unique challenges.
The warehouse holds up to 62,000 parts. The team here are called on around the clock to supply the on-site maintenance workshop and customers around the country.
Yeah, lots of activity, lots of moving parts, lots of people moving with some urgency to get those parts out on time.
And if you see a red tub, that means stop everything and give it right of way. This is for the high priority urgent order. It's extremely important that jobs in the workshop aren't delayed waiting for parts.
We have 24/7 round the clock here, and some of our workshops are working into the evenings as well. So it's important for us to service those workshops, make sure those guys are on the spanners, trying to hit those promise dates for the customers, stay busy and stay on the spanners.
With new parts at the ready, every truck in the workshop is working towards a back-in service date at the mine.
It's all about production for our customers. So the minimum amount of downtime they can have, the better for them. So yeah, the pressure does turn on, definitely.
With delivery deadlines looming, keeping the wheels on in the workshop might be Graham's biggest challenge yet. Back in Newcastle, a mega bucket change on a 47-metre high reclaimer is underway. This massive machine scoops up to 9,300 tonnes of coal every hour from stockpiles onto a network of conveyor belts, which move coal to the ship loading facilities at the Kooragang Wharf. When he started on the job, Cannon Ford was overwhelmed by the size of the machinery.
Massive. It's pretty much an apartment building. When you see it, it's really hard to describe the actual size of it. But to put it in layman's terms, this is how I explained it to my mum. The teeth from the bottom of the bucket to the top to the bucket wheel there, that's taller than me. And there's 10 of them on the outside of the bucket.
And a maintenance job at the very top of the reclaimer would take you up to 14 stories high.
So you're walking up probably 20, 30 stairs just to get to the bottom level. There's a lot more after that as well if you want to go further.
With the bucket attached to the crane with chains, Booker and his team are ready for the next crucial step: the removal of pins holding the 2-tonne bucket to the giant wheel. Armed with a sledgehammer, the hard labour begins. That's one pin out, another to go. But it's not moving. Could this be the stuck pin problem Booker has encountered before? Not this time, and the pin's out. The 2-tonne bucket is now fully suspended by the crane. Working with mega machinery also means mega danger, so there are stringent precautions in place.
Worst case that could happen would probably be if the bucket just fell and somebody got in the way, which we have controls in place to stop that. So the major thing with this is the size and the weight of it, and also where the centre of gravity is, so it's quite an awkward thing to try and put on a crane.
With the bucket safely on the ground, the chains are removed and the crane prepares for the next manoeuvre.
Come back out, come under and grab it again underneath, and then take it out.
While preventative maintenance takes reclaimer 412 out of service, the consequence of a breakdown due to bucket damage could impact ship loading, delaying departures, running into a costly scenario.
Anything that's potentially going to break down, if it's not going to make this maintenance schedule day, we can then pull it out of service, do the quick repair and make sure it's back in service. But that generally incurs a delay, and that's what we don't like to do.
With the job at the halfway point, time for some clean-up work in preparation for the new bucket. At the New Ackland Coal Preparation Plant, it's been a disastrous start to the morning. Work has come to a grinding halt with a massive 12-tonne machine broken down on the job site. It's a major headache for Andy and Rob, and now adding to their problems is a forecast of heavy rain. But they've taken on the challenge and are determined to find a solution. The telescopic boom operates via a network of sensors, and if the boom is extended, the front stabiliser jacks will be outstretched and the machine will remain solid and unshakable.
And it's a safety thing, like if you are lifting a weight and you've got the boom out a reasonable distance, the last thing you want to do is hit a lever and let one of your jacks down a little bit. You could tip the whole thing over. So it's just a fail-safe mechanism.
Armed with a trusty screwdriver, Andy probes the damaged sensors, hoping to manually override the stabiliser mechanism.
Nah, mate, probably not going to make any difference there, I'd say.
Rob and Andy take on the old adage, if at first you don't succeed, try and try. The instruction manual. Armed with some additional knowledge, Andy thinks he might have found the solution.
What's that showing now? Showing the jacks want to come up, but it's locked, so that's where it needs to be. There must be another sensor somewhere.
With precious time slipping away, they're desperate to find a solution to raise the stabiliser jacks. And just as forecast, a heavy downpour dampens the mood even further. Every minute equipment is down costs thousands of dollars. And this lost time weighs heavy on Andy's shoulders.
When it rains, all the work outside stops. Can't keep working in the rain when you've got electricity and welders and stuff happening. Sort of another hour that we've lost here now.
With the rain easing, the boys are back at it, desperate to get this metallic hulk moving. In one last-ditch effort, they decide to try and defeat the electrical system.
Put on the override, Robert.
There's lots of little sensors in there, and we probably damaged and cut some cables when it failed before.
Despite all efforts, even resorting to the manual, still no luck. With one mighty obnoxious machine to deal with, the pressure's on Andy to come up with a solution to get the telescopic handler moving. Back in the heavy maintenance hangar, where planes in this world-famous fleet get some industrial-grade care and attention, one job that's been a hard nut to crack has been the installation of a new pintle pin in the landing gear of an Airbus A330. And after finally getting the pin in place, the lamies on duty have hit another problem, this time with the locking nut.
It hits a stop. Well, pretty much like the thread comes to an end or something.
Yet again, this troublesome part is delaying the job.
Like you said, it just stops. Yeah.
Team leader Charles Lacina is on hand to help solve the issue.
Well, the problem is the nut that holds us in place, we're reusing the old nut. The old nut goes fine onto the old pintle pin, but won't go onto the new pintle pin, so we're not sure why.
The last thing the team needs now is more troubleshooting. Elsewhere in Hangar 3, it's smooth sailing. This landing gear is being prepped for a special voyage. Loose components are being secured to reduce movement in transit and avoid any damage to the hydraulic lines or the landing gear itself.
Getting transported overseas on a boat, I have to make sure that all the electrical harness is capped properly so that no contaminants get into the end of the plug, and also that all the hydraulic lines are properly blanked and they're not going to leak onto the landing gear.
While the landing gear will be travelling by sea, people power will deliver this door to its final destination. A short walk and the team is all set to reinstall this main landing gear door. When the landing gear is raised, the door is required to safely seal the area and creates smooth airflow. The crew methodically and precisely work through the process.
This is the install for this gear door, and we are following the install for these mount points right down to the exact torque settings supplied by Airbus, right down to the nearest inch pound.
Back with the pintle pin installation, it's a different story. The team are still working the problem. To keep moving forward, Charles is sourcing new parts, while the team persist, using their combined knowledge and experience, searching for a cause and any solution.
We've got a choice. We can order out another new pintle pin, we can order out a new nut, or we can put the old pintle pin back in. And I think what we're doing now, just as a temporary measure, is putting the old pintle pin back in to stabilise the installation of the gear.
It's an important decision for Charles, but safety won't be a compromise. This mega machine picks up coal from 65-metre high stacks, loading onto a network of conveyors to a ship loader at the Kooragang Terminal Wharf. Each year, over 1,000 vessels are loaded around the clock. Reclaimer number 412 is an essential part of that shiploading operation.
We have a continuous berthing process, so this machine could be called 24 hours a day, 7 days a week, except for its scheduled maintenance shutdowns, which is scheduled in an 8-week cycle.
This morning, mechanical fitters have removed a bucket showing signs of metal thinning and are now preparing for the installation of a new bucket onto the bucket wheel.
With this bucket change, there's a few different ways you could do it, and over the years they've developed the best way to do it and they've improved the process.
A bucket is collected from on-site storage and placed under the bucket wheel. It's disconnected and the crane hook is guided into position directly above. Attaching the chains, the new bucket is then raised. Booker is ready with the pin and with a technical tap, drives it in. Cannon is on standby to slide in the wedge, locking in the pin. One more pin to go and the bucket is almost fully attached.
A lot of what we learn here during your apprenticeship is how to do things the way that they've taught, the way that they've sort of developed it, and you sort of get into that culture of how can we do this better, how can we improve this for next time.
Over its 40-year history, the company prides itself on its continuous improvement process, constantly innovating and upgrading all aspects of maintenance.
Take notice of the pin over here, it's now hollow. The early editions of those pins are solid, probably about 40 kilos. Now we're down to about 15, so that's a modification that we've done ourselves during time.
With the second pin in place and the wedge to lock it in, the job is almost done.
Those guys that have been here for 20, 30 years, they've got an infinite amount of experience and knowledge that no textbook or nobody could tell you unless they've had that experience.
To finish the job, a wedge on each side secures the bucket in place. The crane releases the load and the job is complete.
The new bucket's been put in now, so the pins are in. As you can tell, we've got different teeth on here. These are used teeth. They were used on a bucket previously. The wall of the bucket is now really thick. You can hear it when you touch it. This will last for the next cycle. There's no telling how long it will be. It'll probably be 18 months, maybe 2 years.
Even with improved, streamlined processes, working with mega machinery still means hard yakka.
Yeah, it's still get in and just get it done. You know, it's still physical work. It's still hard work, especially if we were doing this 2 days ago. It's 40 degrees heat. Doing this in 40-degree heat, changing 3 or 4 buckets a day, it does get a bit taxing on the body.
Yeah, it's a good environment. It's good work, and it's a great bunch of guys to work with. You learn something new every day, which is a great part of the job.
And right on schedule, Reclaimer 412 is back in service and on call 24 hours a day, ready to churn its way through mountains of coal. At the New Ackland Coal Preparation Plant, a damaged telescopic handler and heavy downpours have caused major delays.
No, there's another sensor there.
The decision of what to do lies with Maintenance Improvement Coordinator Andy Schooler, and he doesn't disappoint when he comes up with a simple yet brilliant solution.
We'll just lift it out of the way, mate. Yeah, race is done, eh?
And just like that, Operation Manitou Move gets underway.
You've got to be able to lift it straight onto a truck to take it to be repaired. Just so happens that we have a 100-tonne crane here on site for the 4 days. It's more than capable of lifting it. It's probably about 12 tonne, the machine itself.
Before the lift can proceed, Rob completes a risk management plan to assess the hazards.
If there's anything heavy, well, 2-man or 3-man lifts. Just make sure we help each other out and definitely stand out of the road when the machine is suspended. Have an exclusion zone, which is very important, so anybody around can see, stay clear.
The first challenge, raise the stabiliser jacks.
Take the load off. Yep. Undo those circuits. Pull that pin out, we'll be able to lift them up and chain them up out of the way. Yep.
That's the plan. Time for some manual labour. Success, with the stabiliser jacks secured out of the way. Next up, rig the load. With the telescopic boom extended, the machine will be front heavy. Finding a balance point takes some trial and error. And finally, liftoff. Operation Manitou Move is officially underway. With the telescopic handler safely secured on the truck, the roadway is clear at last. Realising the lost time the breakdown has caused, Rob knows you can't plan for the unexpected.
It's one of those things that happens, you don't like it when it does happen, and you always think there could have been ways to prevent it, but anyway, that's just how it goes at times, I suppose.
Breakdowns are unavoidable, but schedules are not. Making up time is now a priority for Andy.
So all in all, we've probably lost about 5 hours with this on this particular job.
By now, the job should be complete. But with the time lost and a need to get back on schedule, the team will be facing a long haul into the night shift. As the 46-tonne doors slide open, it's the start of another busy day in Hangar 3 at Brisbane Airport. The first tasks have already been delegated to numerous staff on the maintenance team. Some are relatively simple, like polishing paintwork or degreasing landing gear in preparation for shipment. Other work assignments can take longer, even more so when parts are being somewhat stubborn. Yesterday, the installation of this $40,000 pintle pin required a lot of teamwork in and around the wheel well. After troubleshooting by both shifts, the part is finally locked in place. The problem with an ill-fitting nut was rectified by inspecting and intricately cleaning the pintle pin thread.
It's a very important part of the aircraft. It takes roughly on touchdown probably about half the load of the aircraft.
That's around 90 tonnes of the aircraft's weight.
It's an incredibly important component that needed to be changed.
It's teamwork that ensures these enormous aircraft are well maintained and safely back in the air on schedule. But just because the pin is in doesn't mean it gets a passing grade. A retraction test, also known as a gear swing, must be performed. It's one of the final checks where new and overhauled landing gear has been fitted. With the engineering crew in communication with the team on the flight deck, everyone is on standby for an instruction to move the landing gear lever on the engineer's call.
You right? Right. Hydraulics!
A gear swing retraction test takes an hour and a half to complete. And during that time, the landing gear will be put through its paces up to 6 times. It's thumbs up as the new pintle pin passes the vital swing test. An impressive end to another busy day inside this massive hangar. Back at the mine shop in Mackay, a recent upswing in the mining sector has led to unprecedented demand for rebuilds on these heavy lifters. Seeing overworked old machines get a new lease on life is something Graham is proud of.
It's a good feeling when we get a machine and even when it's getting close to the end and we're putting them final touches on, giving it a little bit of a spray paint, putting them stickers on at the end. It really, you do get a sense of achievement.
The 793 trucks have 2 front wheels and 4 on the rear, an inner and outer wheel. One of the final stages is refitting the wheels for delivery of the rebuilt truck back to the mine site. Each one has to be buffed and cleaned before going back on the truck. Using an overhead crane, slinging the huge 3.5 metre diameter wheel into position is a slow procedure. The tyre weighs in at almost 4,000 kilograms. That's 570 times the weight of a standard car tyre. It's a slow and careful process, lining up multiple bolt holes.
Like customers always say to us, if the machine looks good, the guys do look after it.
By the time a Cat 793 is ready to go back to the mine, it's taken a 100-man team working 28 days of round-the-clock shifts.
We pretty much receive a machine every week and send a machine every week, so it's a lot of anxiety, but a lot of reward comes with it.
And as soon as one truck rolls out, another is already being stripped down bolt by bolt to start the entire rebuild process all over again. Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. From deep underground to high in the sky, these heavy metal marvels are essential to our daily lives. But what happens when these massive machines break down? Teams of mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet. Doing the vital repair work to keep these heavy metal wonders of industry alive. On this episode of Mega Mechanics, at the world's largest coal export terminal, high voltage cables are causing some real problems for leading tradesperson Dan Wilk and his team.
There is 6,600 volts running through this cable.
A shutdown is ordered, but before anything is off the ground, there's an issue.
We've come into unexpected dramas that we hadn't allowed for.
Big bulldozer rebuilds have the heat on Shane Johnson to stay on track at the Hastings Deering Mine Shop in Mackay.
When's the pressure on? When the customers failed another track.
Bringing these mega machines back to new takes temperature and tools to the extreme.
So we've got basically an overgrown MIG welder.
And at the New Ackland coal mine, solving the problems that keep the wheels in motion is the job of the breakdown crew.
We can get something very minor to something very major. Every day is different.
The team receive constant calls for help to make sure the mine's mighty machines stay on the move.
This one here, we've got a coolant leak.
Ian Parry has alarms sounding and a train weighing in around 130 tonnes raised in the air.
We can't get the framework down, so something's not married in properly.
He needs to get rolling and remove a motored wheel set, but safety is the #1 concern.
Hey Ian, is it safe to take this out now?
Port Waratah Coal Services in Newcastle, New South Wales is the largest coal export facility in the world. With an export capacity of 145 million tonnes of coal, around 1,200 ships are loaded each year at the Port Waratah Coal Terminal, bound for destinations across the globe. Being the #1 global leader requires ongoing preventative maintenance, led by Superintendent Ross Van Dyke.
We have a team of tradesmen and supervisors that work on a daily basis. So we have 46 all up, that includes 2 supervisors, so 24 fitters, 22 electricians. We work 24/7. But from a maintenance point of view, any sort of delay and any mechanical or electrical breakdown can have effect on the coal chain.
Meeting the demands of multi-million-dollar coal customers in Japan and Southeast Asia means one machine down could delay delivery. And right now, there's a fault inside the main power cable on one of the big guns. Reclaimer 411 is heading in for a super-sized service, and electrical specialist Daniel Wilk is on the front line.
The reason we're changing this cable is the fibre optic core has failed inside the cable, which is important because these machines are autonomous and they need to communicate with each other, and without that fibre optic cable we can't do that.
Repairs of this magnitude take months of planning and cost hundreds of thousands of dollars. But the advanced technology that these bucket wheels need to function cannot be compromised. The job schedule will mean 10 days of shutdown, which has a huge cost in lost productivity. So the decision has been made to capitalise on this time and also repair fatigue damage on the cable reeler. Each bucket wheel reclaimer has its own cable reeler responsible for winding and unwinding kilometres of high voltage cable as the machine moves around the yards. For this job, the cable will be cut and removed from the enormous 10.5 tonne rotating cable reeler, which will then need to be taken off-site, repaired then returned for reconnection. The cable and cable reel have both been faithfully in service for more than 18 years, and today they're coming off this mega machine. To get the job started, it's time to hit the brakes, cut the power, and cut the cable.
There is 6,600 volts running through this cable, and we've isolated everything and we've earthed everything ready for it to be disconnected in a safe manner.
Cutting through high voltage cable with a power saw poses dangerous risks. Consequences from human error can be fatal. Dan's team of experts must sign on to a high voltage permit to give them authority access.
Gab's about to cut the cable. We've got a power saw there ready to go. We're not sure how this job's going to go, but it should take between half an hour or it could take 5 minutes.
Gav packs muscle into hardcore sawing at the power supply box. He's through, but it's not time to pack away the power tools just yet. The cable also needs cutting from the reeler itself. The cable contains a fibre optic core, 2 low voltage control cables and 3 high voltage cable conductors.
The end of the trailing cable coming through the middle here, and then we terminate those onto the slip ring on the inside, and these brushes bring the power onto the machine itself. 6.6 thousand volts travels through those slip rings, through these brushes and onto the machine to supply the machine with power. This cable reel is 18 years old, and so it's time to give it a good birthday.
Peter Anshaw and his lifting crew move straight in to assess the removal, refurbishment and reinstallation of the reeler.
What's the scope of work? What are the hazards? What are the controls? And what are the other activities that the other people that we might have conflict on the machine?
As the 100-ton lifting crane heads onto site, Peter's team are finalising access, electrical work and bolt removal.
Have to set up the access scaffold onto the belt in our working at heights static line. That allows the guys to remove the base plates in the bottom frame. We've got electrical guys who are disconnecting the 6.6 from the slip ring housing. Once the pendulum out, the bolts are removed.
With the job as big as this one, Port Waratah's terminal manager Wayne Carman is on site to support his staff.
Part of the maintenance guys' deals is that they take the machine, they do the repairs, they return it to us in a timely manner, and that when they've returned it to us, the operators can push the button and it goes.
Everyone knows there's a need for speed to get Reclaimer 411 back in business. But for Wayne, there's only one priority.
It's about making sure that we give the guys enough time to do it safely, in a controlled way, in a planned way, rather than put pressure on people. We don't do that. They know what's got to get done and we'll get an update.
The question is now, are Peter and his crane crew good to go?
At this stage, I can't see anything holding us up.
But has Peter spoken too soon? 950 kilometres north of Brisbane is the coastal city of Mackay. Nicknamed the sugar capital of Australia, the region also benefits from a large mining operation in Queensland's central Bowen Basin. Home to the state's richest coal seams, with over 37 open-cut mines and 13 underground mines in operation. The recent spike in coal price has upped the demand for additional heavy machinery to work the mines. The Hastings Deering Mine Maintenance Workshop in Mackay is a massive service centre with 750 employees from trade specialists, part suppliers and support staff. Shane Johnson heads up the Track and Weld division. His team are specialists in the field and his workshop one of the busiest in the country.
So tracks are what moves your dozer. They go on your track frame, so that's when your dozer's moving forward, they're gripping the ground and pushing your dozer forward or back. So they're a high wear product on the machine. They're in contact with the ground all the time, and you've got the whole weight of the machine being pushed by these one parts. So they're always getting worn in high corrosive or high abrasive conditions.
In the workshop today, a Cat D11 dozer is in for an overhaul that begins with its tracks. The tracks on this 100-ton mega machine weigh over 6 tonnes each. Made up of 41 individual plates called shoes and 164 bolts, the track must be dismantled piece by piece for full reconditioning. The first step in the process is to get the shoes up on the press. On these bigger dozers, they can be almost a metre wide. The plates are either machined clean or an epoxy paint is applied to stop corrosion. The shoes are attached to the track chain, a series of massive links, each of which must be taken apart, cleaned, resealed, oiled and tested for leaks. 16 tracks a week are cleaned and reassembled. In a 7-day rotation, teams work shifts around the clock. It's the workshop that never sleeps. 40 hours in total for one track is the budget target. But if it's from a dozer that's been on a coal stockpile or salt water, there's extra machining and blasting needed to get the corrosion off, blowing it out to a 56-hour task. This makes Shane's job scheduling maintenance a constant juggling act.
When's the pressure on? When the customer's failed another track and they need that track back to replace the one that's failed.
Work on the shoes and chains of a dozer track takes several days of around-the-clock attention. But that's just a small portion of the hundreds of tasks to complete a full overhaul, which will see them out of action for 6 weeks. And the next component needs an unusual combination of fire and ice. 25 kilometres from the township of Oakey in regional Queensland, the open cut pit at New Ackland Coal Mine is already a hive of activity this morning. Keeping the site's huge fleet of massive machinery on the go is a round-the-clock job for the breakdown crew, a group of experienced mechanical fitters.
Most heads for today. H401 restricted sump. Those underground diggings there. Possible gas.
The team constantly travel across the site, and for Nathan Sutton, his first port of call is Dozer 611. This beast of a machine is a Cat D11, the largest dozer in the fleet. It packs more than 800 horsepower, but it's not up to its usual fighting form. The dozer has been given a stop work order because of an issue with the relief valve. Relief valves are used to regulate pressure in the dozer's hydraulics. Too much pressure and the system could literally blow apart. But too little, which is the problem on this dozer, and there's not enough pressure for the hydraulics to function correctly.
We've had the job try set the pressure again, but the spring's obviously too damaged and won't get correct pressure.
Unfortunately, the replacement part the team needs isn't on hand. So while it's sent for from the warehouse, there's a 102-tonne mining truck in need of attention.
Just run out of air. Needs air to start.
The air-driven starter motor just needs a dose of compressed air, and this 5.8 metre tall monster truck is back in business. It's not the only mechanical beast that's running low on air this morning. Craig Jackson in the supervisor's office calls Nathan on the two-way radio.
35 to 36, Nathan.
Yeah, 36.
Nathan, 008, water carts reported POS 6 flat tyre.
All right, I'll go check her out.
Water trucks are vital to mining sites. They control dust and also play an important role in fire prevention. With a full tank, these trucks can haul 150,000 litres of water. With one of the 4 rear tyres blown, that's a huge weight for the others to bear. So letting the sprays run is the simplest way to fix that. The solution is a new tyre. At over $26,000 each, it's a trip to the workshop for the tyre change. Now Nathan can return to Dozer 611. He's been advised the new relief valve is on its way, so he's under the pump to get this 102-tonne machine prepped and ready. He's on target for now, but not if any emergency call-outs come through. In Australia's third largest city, Brisbane, the main rail depot is the epicentre of city train maintenance. On average, 53 million people travel on passenger trains every year, and schedules need to run on time. Even the smallest issue can have a compounding effect. So when a train not getting full power is reported, it's returned to the maintenance depot for analysis. It's up to working group leader Ian Parry to rectify the issue and get this train back on the tracks and fully operational for the PM peak.
We're going to be taking out motor 3. We've had a report saying that it's out of round. What that means is that the bushes aren't going on the comms inside the motor. So what it says is that when it's out in traffic, you're only getting 7 motors driving the train instead of 8.
Ian Parry has been a fitter and mechanic across the world, from steelworks to shipyards, and now to trains, where he's become a specialist in what they call the jacking road. The jacking road has 12 pairs of jacks, one to support each axle of the 3-car train as it's raised. Then, to be able to access an individual wheel set, body supports are brought up, enabling the main jacks to be lowered. The wheel set can then be removed and have its motor changed over. First, Ian and his apprentice Dale Westthorpe raised the body supports.
Well, if you didn't have the body support up there, you can't do any other thing on this machine. You must be in this mode. If you didn't have these up, and you bring your whole support down.
With the body supports in place, Ian extends further safeguards to balance the 130 tonnes of train currently raised in the air.
The safety on this is mainly on the motor itself. You've got to have a scissor lift underneath. You're looking at least 1 to 1.5 tonne on a motor and a wheel set, so you've got to be careful all the time.
There's also a schedule to keep and a lot of work to be done to get this train back on track. The team are well aware of the safety risks, constantly weighing up the hazards and planning accordingly.
We have a dedicated team over here, and we all know what we're supposed to do. Everybody knows their job, and obviously we still go around, we look after everybody else. The main thing is that with having a dedicated crew over here, we're reducing the time on how long it takes to do these sort of jobs.
Electrician Damien Fuller is on site. He's made short work of disconnecting the necessary cables.
Now we've gone into a different mode because we want to drop it down 50 mil. Then we can get the jacks out.
But the system has locked and won't budge. It's a sophisticated series of checks and balances on a piece of machinery that Ian is an expert in operating. Will his experience shine through and get the engine changed over in time for the PM peak? Back at Port Waratah, Peter Anshaw and his crew are ready to lift out the 10.5-tonne cable reeler from Reclaimer 411.
We've got the 100-tonne crane come in from Boom. Once he loads the counterweight, the boys are going to reverse up the ramp, come in here, parallel with the cable reeler, and that'll give us around about a 16-metre radius. We'll be well within the lift zone there, ready to lift it off.
Peter's got to stay on schedule because this reeler needs to head out on the road for a major off-site repair.
And we've got our other off-site contractor. He's on the phone this morning, you know, when are we going to see it, because they've got a lot of work to do and they want to get that underway.
The team at MCM Manufacturing know they have a tight turnaround to repair the reeler, so they're gearing up to receive it. Back at base, the spreader beam is winched into place.
When the lock's going on, then we're ready to go. We set up the barricaded area, get our equipment up onto the machine, and we get started. Everything going to plan, we'll be on target.
A smile of relief from Peter as the lift begins. But the crane driver signals a problem.
We've come into unexpected dramas that we hadn't allowed for, and we started the lift. What we found, we had 3 corners of the cable reeler. It lifted with the crane. He reached his 10-tonne capacity.
Hydraulic cylinders on the back of the crane, required to stabilise the vehicle, have paralysed Peter's plans.
We can't get him up, we can't get him down, so we've come to a halt until the mechanic gets on site and hopefully gets us out of trouble.
This is a disaster for Peter and his team. Their schedule is now way off track and time is ticking.
Put us behind because we've got a crew in the workshop eagerly waiting for the cable reeler to turn up to get started.
The delay has a domino effect. Jeff Gaddies is waiting to transport the reeler on his truck to MCM's fabrication workshop.
A lot of times you get hold ups like this, and you know it's out of our control. So you just got to sit there and wait and grin and bear it.
MCM are waiting to refurbish the reeler. Dan and his crew are waiting to replace the cable. And Terminal Manager Wayne Carmen is waiting to get Port Waratah fully operational. This is a serious setback.
My job is to make sure that the plan that's developed, I deliver. And when I say I deliver, I'm accountable for it. And obviously Ross, being the maintenance superintendent, will let me know if something's starting to go haywire.
After suffering a 4-hour stoppage, the crane is now given the all clear and Peter's crew are under the pump.
Yep.
Chain locks are secured and final checks are made before the big lift.
There's two gussets that sit against this wall here.
Now fully suspended, this is a tense moment for the crew. There's a lot of money, not to mention time and effort, up in the air. And a slip, a gust of wind or a failure of the crane could be catastrophic for not just the reeler, but the crew. It's all in the crane operator's hands. Cautiously, he manoeuvres the cable reeler and, showing his skill and precision, guides it safely down. Finally loaded onto the truck, there's not a minute to lose. But the truck carrying the reeler has come to a standstill.
Because of the size of this reel, it was just on the 3.5 mark. I can't go anywhere with it, so I had to just sit outside the gate and wait.
Load restrictions on public roads means the reeler is too wide to travel in peak hour traffic. They've missed the window of time to get it out in daylight. Dan's day is going from bad to worse.
I get a bit uneasy when there's times like this. We need to get moving. It's kind of that time where you're sitting still and you know you've got to do something big, and you know you're going to have to work a bit harder later on to make up for this time.
While Jeff, his truck and the cable reeler take a break, the repair team are waiting in their workshop, losing valuable hours. Will they have enough time to be able to repair the reel? In the Mackay Hastings Deering mine shop, the track team is working around the clock to carry out a midlife service on the Dozer tracks that work the Bowen Basin coalfields.
Hey mate, how's this one going? Yeah, not too bad, bud. Just about to put the bearings in. All right. Well, I'll get out of your road and let you get back to it. No worries.
And today, it's not just mechanics, but science that's helping things along. In the Dozer track frame sits the pivot shaft bushes. This is where the track frame mounts onto the Dozer. The shaft is constantly rotating at angles to accommodate the terrain. For dozers working at least 20 hours a day on a coal mine, that's a lot of wear and tear. The midlife service for these parts means a good clean and then refitting with a perfect seal, which involves a process called an interference fit. The pivot shaft bushes are submerged into a tank of liquid nitrogen at minus 200 degrees Celsius for around 10 minutes. In that time, the metal shrinks. On the floor, the track frame space that the bush has to fit is heated with a gas torch. With one metal part expanded from heat and the other contracted from freezing, there's a very short window of time for one to slide into the other perfectly.
Straight in.
As each part returns to ambient air temperature, friction holds the pivot shaft bush in permanent place. But if it's not timed just right, or if the track frame has cooled after heating, the bushes expand back to size rapidly. That can mean a little bit of old-fashioned coercion, inserting a drift slide and hitting with a sledgehammer. It's vital the bush seats perfectly. It takes much of the load of the 91-ton Dozer. A poorly fitted bush won't last the next 8,000 hours of work it has ahead. Even slightly off means cutting the part out and starting over again.
Happy day. Good.
And if you thought these guys had a tricky task working with sub-zero temperatures, the next rebuild in the Dozer workshop involves an arduous 10-hour shift at a scorching 300 degrees. The New Ackland mine in Oakey in outback Queensland, a place where temperatures can soar above 40 degrees Celsius. Challenging conditions for a challenging job. The extraction of over 13,000 tonnes of clean coal every day. Keeping the coal mine's extensive range of mega machinery running smoothly is the breakdown crew, an experienced, dedicated team of mechanical fitters. So far, Nathan's shift has seen him called out to deal with a few mining trucks.
3.6 to 3.5.
Yeah, got you, buddy.
Yeah, no good on that injector.
And a water cart with a flat tyre. Standing at over 4 metres, this monster towers over the mechanic working to get it back on the move. So do the tyres, each one nearly 3.5 metres tall and weighing in at 3 tonnes. One machine that's been a real attention seeker this morning is this 11-metre long hulk, a dozer with a damaged relief valve. This is the second time Nathan's been inside its belly today. A replacement part has been ordered, and Nathan's racing the clock to get this 102-tonne dozer primed for the installation. Every working minute lost out in the pit means less production, so it's crucial to get this mighty machine rolling again as soon as possible. The new valves arrived, along with another mechanic, and with 2 on the job, this beast will hopefully be back in business before the shift ends. Elsewhere on the mine, Mark Garth from the breakdown crew has been called out to check on truck number 311.
This one here, we've got a coolant leak. The header tank's got a leak on it somewhere. He obviously was on a break or was driving and noticed the coolant leak and pulled her in and called her up.
It's a 4-metre climb to get up to the cabin.
The gauge is showing empty. Maybe the operator hasn't seen any leak as such. Maybe he's just saw the gauge.
When huge machines like this are operating in extremely hot conditions, it's better to be safe than sorry.
Looks to be plenty of coolant. I'd say just got a faulty gauge.
A quick inspection proves Mark right.
Yeah, keeps it coolant. No problem. I'm probably just going to send it back to work and see how it goes.
And with that, Mark heads off to another call-out. Safety is the number 1 priority for Ian Parry and the team on the jacking road at the main rail complex. They're going through the final checks before removing a 1.5-tonne motored wheel set.
You need people there to help you out and support you, and lifting things especially, a lot of heavy components.
It's a complicated job, but one Ian Parry is a specialist in.
You've got to lift the train up, you've got to support the carriage, and then to simplify it, you put a trolley underneath, take it out, get a new one built up, put that back on the trolley and back up again, and reverse all the things you've done the first time.
With a clear plan in his head, Ian needs to drop the jacks down, but movement is locked.
Come down.
The safety interlock on the jacks will prevent any unsafe conditions. These checks and balances are designed to protect the workers and equipment. The alarm is sounding, and it's Ian's job to find out why. He knows from experience it's just a matter of going through the process in fine detail. Nothing needs to be rushed.
We can't get the framework down, so something's not married in properly.
A delay could impact schedules, and if there's an issue with the jacks that can't be resolved, no work will be able to continue. Will Ian be able to silence the alarm and get back on track? Overnight, Port Waratah's damaged cable reeler finally made it to MCM's fabrication workshop. Richard Tate and his team wasted no time in getting on the tools.
We lost about 4 hours because of a crane malfunction. We've had 6 men round the clock from then.
MCM have been commissioned to refurbish the cable reeler. It's a gigantic job, and these guys won't stop until it's finished.
24 hours a day for 4 days. 6 men on each shift.
With the cable reeler in the workshop, Richard can properly assess the cause of the problems.
It's time by vibration, the actual motion itself. It's being such a light fabrication as it rolls, it fatigues, and we're repairing fatigue cracks.
This is a critical repair. The cable on Reclaimer 411 weighs over 15 tonnes. As the Reclaimer moves, the cable winds around the spokes of the reeler, called spiders. A breakage could not only tangle and damage the hundreds of thousands of dollars of cable, but could result in a massive arc flash or electrical explosion. To ensure the reconditioned reeler is safe and strong enough to last another 20 years, Richard inspects every detail.
They're going to be a tight fit because I think the existing holes are 22 mil.
Back at Port Waratah, Dan is feeling the fallout of unprecedented delays to his schedule. Can he claw back time while the reeler is off-site?
Just inspecting the electrical components from when the drum's been lifted, checking that they're all still intact and ready to go to be reconnected. So while that's off-site, we're doing work to refurbish a lot of that gear for when it returns.
Steaming ahead, Richard at MCM is confident about getting the reeler back on the road.
We've got another shift and a half to go, and it's well ahead of schedule. It's well planned, well manned, blokes know what they're doing.
A final push and MCM finish in record time, a day early.
And now we're miles ahead. It should make them very happy.
And here it comes. Jeff trucks in the newly refurbished cable reeler.
Reeler's turned up a day early. Boys out the shop at MCM have done a fantastic job to get us where we are today. Not only the time frame, but the quality is first class. Very happy with the quality.
Dan is also a happy man. His shutdown is now back on schedule. It's all hands on deck, and Dan is ready and raring to get this reeler back in. There's only 100 millimetres of clearance. It's a tight fit. 20 bolts secure it onto the machine, and the refurbished reeler is in.
Overall, our job on the cable reelers, it's gone very well.
All that's left to do now is wind on the cable and reconnect power. With such a straightforward task, what could possibly go wrong? At the Dozer track division of the mine shop, constant shift rotations means these bays are in action continuously day and night. Currently, they're tackling dozers due for their mid-term service after working 8,000 hours on the coalface. The team must completely overhaul each machine. The next part for restoration is the idler, part of the undercarriage which bolts onto the front of the track frame and guides the rollers to line up the track with the load rollers underneath. The idler rotates constantly with the track as the machine moves, in operation day and night. The metal-on-metal fatigue from the track chains wearing against the idler takes its toll. The overhaul involves an arduous, sweltering process for both mechanic and machine. If the idler steel face is worn below 70%, it's hitting a softer, mild steel surface, which means a complete re-weld to build it back up to spec. An LPG burner is fired up to a heat of over 300 degrees. It's then applied at a constant rate to the surface for up to 10 hours.
If the idler gets below a certain temperature, it'll actually start to crack the surface, and then we have to throw the idler away and start again.
In the 30-plus degree tropics of Mackay, that constant heat is a concern for workers like Terry. They have to make sure they take fatigue breaks and stay well hydrated, always mindful of keeping hands well clear of that searing flame. With each rotation, the wire forms the base material for the weld and builds up the surface of the idler.
We have a flux granule, so that pours on top, and the weld's performed underneath that grain to keep any impurities out until it's cooled down, until we chip it off for the next weld run.
Once the 10-hour weld is complete, the idler is put in a hot box to cool gradually. A midlife service also means a complete engine overhaul. The D11 Dozer engines weigh up to 4.5 tonnes. Depending on the state they're in, the engines are either reconditioned or a brand new one is dropped in.
Once this is done, we'll put that next one.
And just as one dozer heads back to the mines, another is being pulled apart and rolled into the workshop, ready for attention. It takes 8 people every day around the clock for 6 weeks straight to get one of these machines broken down, cleaned up, and back out to site again. It's a massive amount of manpower. But for the machine, it's now set to face another year working 20-plus hour days, pushing coal. At the New Ackland mine near Oakey, it's the start of another busy day. The breakdown crew are ready to roll. The main focus of this team is to quickly attend to breakdowns and solve the issues as fast as possible. But they do have other duties.
We get a list of minor defects that we have to get to. Our day can involve us just going to fix a light bulb or wiper or something like that, or to a breakdown where tranny has failed and we may have to pull axles and tow it back to the workshop. We get something very minor to something very major. Every day is different. Don't know what to get.
Truck number 503 is his first call out. A loose cable needs to be secured in place.
So basically this job here is just a simple job. Just put an R-clip on that pin there, stop that from falling out. 5 minutes now, saves half an hour later.
With the truck bed lowered and the ladder raised, number 503 can roll back into action. And Mark can make tracks to his next assignment, a broken down excavator. Attaching his personal lock to isolate the power supply means that no one can start or operate the machine, so he can safely get to the heart of this digger's issues.
The belts are still on.
Well, I found the problem, Sammy. It's only the exciter wire. It's just popped off. Most of the time you can pick it easy, it's low voltage, so just the exciter wire come off the alternator, so we won't know for sure. We'll chuck it on there and crimp her up a bit better and fire the girl up and we'll see how it runs.
Mark's connected the wire he thinks is causing the issue, and for good measure, he removes a seized hinge on the engine door. A quick fix that a boilermaker can repair properly later on.
At least for now we can shut the door.
With that locked off, time to see if Mark's hunch about the loose wire was right. As Sam revs the engine, it seems it was. And now, it's all good to go. Mark packs up, and it's off to check on Dozer 618, a machine that's going nowhere fast.
Got track tension problems.
This powerful D10 bulldozer rips and stacks coal in the pit. It may be the little brother to the D11s, but at around 70 tonnes and reaching nearly 4.5 metres to the canopy, it's definitely not small.
What we've got here, we've got loose track. Boys have tightened it up last night and it's come down again. They've got a bit of grease into it last night and obviously it's got a problem internally there by the looks of it. So what we'll do now, we've got a service truck coming along, we'll pump it up again.
These machines are battered with tough conditions, but a bit of TLC from Mark and they've soon got a new lease on life.
We try and nurse things through too until we get a space in the shed where we can get jobs in, keep the grease up to it until we get a bay free.
Grease is applied to try and prevent excessive wear, but while this is a quick fix to get things moving, it doesn't solve the larger problem. If left, a loose track can cause even more issues with the machine.
It just wears everything, it'll wear the track frame, it'll wear your chain, all your idlers.
Looks like this beast of burden will need to be called into the workshop for extensive repair work. The safety warning alarm is sounding at the main rail complex in Brisbane. The sensors on equipment supporting more than 130 tonnes of rail cars have alerted the crew to an issue. The pressure is on Group Leader Ian Parry to work out what it is and how to solve it, so he can access a motored wheel set that needs to be removed.
Have any of these lights out?
Yeah, that's fine.
All right.
Hopefully, the solution is as simple as replacing a slide.
Coming up. Right, coming down.
If Ian's solution has worked, he should be able to get the motored wheel set out and on the scissor lift.
Right, try again, eh? Well, it's worked. Sometimes it just jumps out of sync. It might only be a few millimetres and that'll stop all operations.
Success, and finally Ian is able to drop out the bulky jacks from under the motored wheel set. Now, with the motored wheel set on board, the trolley rolls along the tracks to meet the overhead crane. The 1.5 ton piece of machinery is carefully lowered onto a specially designed rest.
Check it out, mate.
One of the chains is disconnected to free the traction motor. Then it's guided to a location where the two pieces can be safely separated. In order for a new motor to be fitted, the gear cases are removed and the old motor disconnected. The gantry crane again swings into action to deliver the wheel set to the newly reconditioned motor.
Yeah, just get a bolt in there and it'll bolt it down. We've just got 2 bolts and it's all you need. You got backlash, but once that's down, it'll go.
With the wheel set fastened to the motor, Ian checks for the all-important backlash.
Got backlash in that.
The team install a copper shim that's about 0.4 of a millimetre thick, which creates the space or backlash, opening up a small space between the gear teeth that allows for lubrication.
Yeah, come down a little bit more, mate. Hopefully that should just line straight in. It's gone in.
With a bead of silicon to ensure the gear case join is watertight, the motor and wheel set are ready to go back into the train, and in record time. But they're not out of the woods yet.
Hang on, mate, do you want to put that thing in that bush? Put your feet.
The 1.5 ton wheel set and motor is transported back on the scissor lift, lined up precisely with its installation point and raised into position.
Put a bit more, Dan. A bit more.
The new traction motor is secured to the bogie of the train with a bolt through the reaction arm. This is what stops the motor from rotating on the axle and instead transfers the force to turn the train's wheels. Now secure, the main jacks can again be raised to take the weight and the scissor lift brought down so the undercarriage can be accessed.
Hey, is it safe to take this out now?
Yeah, of course it is, mate. Yeah.
Bolts tightened, electricals reconnected, and the team can celebrate a job well done.
I think it's a sense of achievement that you've done a job and everybody's safe, they can go home safe. And it's like a bit of a buzz, it's an adrenaline rush. It really is an adrenaline rush. And I like doing a job properly.
It's no surprise the train was back on track and ready to roll out with the rest of the fleet for the afternoon peak. Harsh conditions push the staff and the huge machines they operate to the limit every day. And when that breaking point is reached, the mine's breakdown crew are called into action.
35 to 37 Marco, got a copy?
Yeah, copy.
Yeah, mate, we've had a brake failure on 004. Something about the park brakes not coming up. You able to check that out for me?
004 brake failure. Yep, no worries, I'll have a look.
When an issue with brakes is reported, the best way Mark can see what's happening for himself is to carry out what's called a rolling test.
It thinks the front brake lights are on, but they're not. It still rolls. So it's obviously a electrical error, which could be something like a pressure switch playing up, making it think the front brakes are applied.
Opening up the front cab panel, Mark inspects the cart's electrical system. Then heads down to check the brake lines. After scrambling under the truck's belly, searching for clues, and applying all the usual fixes, he can't uncover what's causing the issue.
36 to 35.
Copy.
Yeah, this 004 water cart doesn't appear to be a quick fix. Probably want it down the shed. I found a switch that looked to be unplugged, but that didn't fix it. It'll need a bit more investigation, this.
The pressure is always on to find a fix, and fast. But there's only so much that can be done out in the pit. And Mark knows he's not always going to be successful. But after a short test drive, it looks like he can celebrate a win after all.
Fixed! Maybe it was that plug.
Back at Port Waratah, the pressure is on to get Reclaimer 411 online. Dan's crew are gearing up to finally get stuck into some heavy lifting, installing the high voltage cable.
The cable behind us is 1.3 kilometres long. It's 10 kilos per metre, so it's 13 tonnes of cable. We've sourced this cable from Europe.
It's taken 6 months to get here, and cost nearly $500,000. Today is the pinnacle of the operation, but Dan's hopes of getting the job done on time may have just been cut short.
They were unpacking the cable and we noticed that there was some damage. We've contacted the manufacturer and asked for direction on what we should do next.
There's no backup option, and Reclaimer 411 cannot operate without it. At this late stage in the shutdown, a damaged cable is a catastrophe.
We're waiting for Roger to come on site from Reese, who's going to give us some professional advice on what's required to repair the cable.
High voltage fibre optic jointer Roger Devery arrives to inspect the cable.
It's just outer sheath damage, so we're doing a vulcanised repair, so we'll take the outer sheath off back to where the damage stops. Then we'll be wrapping with vulcanising tapes that won't damage any of the internals of the cable, the power or the fibre optic side.
With a cable repair pending, it's now crucial that Peter and his team stay on target.
We've got some boys on the other side there that are setting up the cable ruler winch ready to wind the new cable onto the machine.
Time to lock on.
The most critical part is getting the cable from this reel and into the machine where we want it to be, and that'll be probably the most difficult thing.
As the cable is wound onto the reconditioned reel, the first loop is critical. They must have clear entry into the slip ring box for reconnecting power.
So the people inside the drum will be forming a little bit of a chain. My main concern is the manual handling aspects of physically using men to manoeuvre this cable.
10 kilos per metre means heavy lifting and long hours. It's relentless, and these guys need a break.
It's going to take some time, and we're going to have to be patient. We don't want to bend the cable too much because of the fibre optics inside, and we need to be able to look after it as we're installing it. So the more the merrier, and less stress on one person, the better it is.
The first loops are secure, and the team use electrical rotation to feed the cable on. With 150 revolutions to go, it'll take some time.
There, another 20 minutes hopefully, and we've got the cable on, and my team can start to put it back together.
Finally, the last of the cable winds on, and Dan gives it his magic touch to tie it off.
Job done. Happy. We've got the job done, and I'm pretty happy.
Running under generator power to complete the connection, Reclaimer 411 does laps to bed in the cable. The beast is awakened. It's back to business, and the big boss couldn't be more proud of his team.
This is just big stuff. So the guys take a lot of pride in it. They really do. There's a lot of pride in making sure it goes well. Nobody's hurt, and it's on time.
Port Waratah is a landscape of giants, and it's a place where the size and strength of mega machines is only matched by the skill and diligence of a team of mega mechanics.